The science of uncertainty is called probability theory. It allows us to evaluate and control the likelihood that a statistical event is correct. Probability theory in general, P of E is equal to NE over NS. It means that the probability of an event is equal to the number of events divided by the number in the sample space. For a true or false question, the probability of truth is 1/2 or 50%, and the probability of false is also 1/2 or 50%. So probability theory provides the basis for inferential statistics. If we take in a random sample without replacement of two officials from the 5, what's the probability of obtaining a governor and a treasurer? We're going to use initials to form the sample space. We have the governor, lieutenant governor, governor, secretary of state, governor, attorney general, governor, treasurer, lieutenant, secretary of state, lieutenant, attorney general, lieutenant, treasurer, and then SA, ST, then what else? AT is left. AT. Altogether, 10 possibilities. AT is Attorney General and Treasurer. Now, out of 10 possibilities, how many have a governor and a treasurer? Without replacement, it'll be this one, governor and treasurer. So we have one governor and treasurer. So the probability of having a governor and a treasurer is 1 out of 10. Which is 10%. Now for B, the probability that when we take a random sample of 2 officials out of the 5, that we have an attorney general included. So because we already have the sample space, we're going to is included in the sample. Okay, because we already have a list of the sample space, let's just take the ones that have the attorney general involved. So GA has it, LA has it, SA, it's the Secretary of State and the attorney, and AT, the attorney general and the treasurer. So probability of having an attorney general involved is 4 out of 10, 4 cases, which is 2/5 or 40%. Theoretical probability is just a percentage. What is it a percentage of? The number of ways the event occur, NE. NE is also called frequency. How many times the event occur. And the total number of possible outcome is the NS, which is the number of event in the sample space. total number of observation in the sample space. So PE is equal to NE divided by NS. It means the same as F over N, which is the number of ways an event occur divided by the total possible number of outcome. Returning to the problem before about the 5 officials in Oklahoma, we're going to list the possible samples without replacement of size 4. We're going to use their initials, and then we're going to look for the 5 possible samples. The most obvious one will be GLSA, Governor, Lieutenant, Secretary of State, and Attorney. Then GLST, then GLAT, then GSAT. Now the only one left is LSAT. Now let's answer the question. We need a governor, an attorney general, and a treasurer. Out of those 5 income, we're going to look for the GAT, the ones that contain GAT, governor, attorney general, and treasurer. We have GLAT, GSAT, and that's it. So the probability of GA and T is 2 out of 5, which is 0.40 or 40%, 2/5. C, probability that the governor and the treasurer are included in the sample, P of G and T. In the sample, G and T, so we have GLST, GLAT, and GSAT. So the probability of G and T is 3 out of 5, 3 over 5, or 60%. Now, the probability that the governor is included, so P of G, and P of G will be 1, 2, 3, 4. So it's going to be 4 out of 5, or 80%. We need to recognize that the total frequency is 77,418, and that the frequency for each interval is given. So the first question asks us for the frequency when X is between 50,000 and 74,999 inclusive, which means X is largely between 50,000 and 74,999. Well, that the frequency is given, it's 15,754, and it has to be divided by the total, which is 77,418. Remember that the probability of an event is equal to the number of events divided by the sample space. So we going to divide 15,754 by 77,418, and we get 0.203. So that probability is 20.3%. B, between 15,000, when X is between 15,000 and 49,999 inclusive. So 15,000 is less than or equal to X, which is less than or equal to 49,999. We have three values that satisfy this requirement: 7,765, 8,296, and 11,301. We add those numbers together, and then we're gonna divide them by the total, which is 77,418. Now the sum is 27,362 divided by 77,418, and we get as a decimal 0.353, which is 35.3%. For C, under 25,000 means less than 25,000. And we have two numbers that strictly less than 25,000. We have two numbers that satisfy this requirement. We have 6,945 and 7,765. We will do the same thing. We will add them and divide them by the total. 6,945 plus 7,765 divided by 77,418. The sum is 14,710 divided by 77,418. We're going to get our decimal from the calculator. 0.19 or 19%. 0.19 or 19%.